Okay, let me start the class. As I said, I'll take for very less time today. Okay, so again, this is not there in the syllabus, but it's come in the question paper before. And it's very, whatever I'll cover today is very easy. And one more slightly difficult problem I'll cover in the next class tomorrow. Okay, so we have already talked about the context-free grammar. And when I defined the context-free grammar and normal forms, I had defined two types of normal forms. One was Chomsky's normal form, which we studied in detail, right? We have converted a lot of grammars into Chomsky's normal form. And I had just defined you one more normal form, and that was called as Grayback normal form. Now, why I'm talking about Grayback normal form is because I told you the fourth module begins with CFL and decision properties. And when we go there, we will require the conversion from, CNF to PDA and PDA back to the grammar, right? Which we did in the last class. We have done this, right? CFG to PDA, we have done that. And no, sorry, I think we have done PD, one of them we did, and PDA to CFG has to be done, correct? Yeah, we did CFG to PDA and we have to do PDA to CFG. Now, for this conversion, CFG to PDA, we chose some grammars and we have solved, but if the grammar is in Grayback normal form, then it becomes very easy to convert it into PDA. So it's not always guaranteed. The problems we took and solved were already in a certain form. Okay, and that's why it was easy for us. So now what we are trying to do is, given any grammar, we want to convert it into Grayback normal form. Grayback normal form. Any context-free grammar. So what is a Grayback normal form? It's a context-free grammar, obviously. So it has all the components of a context grammar, B, sigma, R, and S, along with two new rules. For Chomsky's normal form also we had rules. Similar to that, what were the rules for Chomsky's normal form? A non-terminal can derive two non-terminals, or a non-terminal can derive a terminal. These were the only two possibilities for the Chomsky's normal form. Similarly, for Grayback normal form, the grammar can be in this format. That is, X derives A beta. Beta, again, you can see A is a part of alphabet. That means it's a terminal, and beta belongs to B minus alphabet. Means all other things, all non-terminals. So it's easier than the Chomsky's normal form to write, actually. So when I say X derives A beta, I will write some examples. So A derives AB is okay, or B derives A, B, C, D, E. This is also okay. So there is no restriction on length like in Chomsky's normal form. Here there was a restriction on length, no? That is, a non-terminal can derive only two non-terminals, or a non-terminal can derive a terminal. So in this case, it can be of this format. Okay, so you can have anything, and you can see one example over here, and you can also derive a single terminal. Okay, these two are examples, and also you can derive a single terminal symbol. Obviously, it's required later for one of these to converge into terminals. We will require this. So you can see one example that's given over there. This is a valid example. This is a valid example, right? And A derives B or B derives A, anything. These are all. One thing that we should remember is, in every derivation, when you apply the rule, in every derivation, one terminal is generated. Okay, one terminal is generated for every derivation. So this means what? There is a very straightforward procedure to see whether a W, which means a string, can be generated from the grammar. So very straightforward method. Also, it's very easy to convert an epsilon free grayback normal form to PDF. Okay, so these are the advantages of having that having a context free grammar in grayback normal form. Now I will write a set of examples. You tell me whether it is there in the grayback normal form with the definition that I have told you. I'll write one on the left hand, or I'll write the first one now. Tell me whether it is there in the grayback normal form or not. Please tell me in the chat section. Okay, just see it and tell me whether it is there in the grayback normal form. Is this in grayback normal form? Yeah, please answer in the chat section. Is this in the grayback normal form? Hello, I'm waiting. Answer in the chat section. Is this in the grayback normal form or not? Yes or no? Okay, Suraj answered it as yes. Anyone else? Neha is saying yes. Anyone else? Only 2 people are listening to the class? Okay, Rashmi says yes, Vaishnavi says yes. Okay, let me write one more. You tell me whether this is in grayback normal form or not. Please answer. Is this in grayback normal form? No. The reason it is Kirtana, Neha, Rashmi, Vaishnavi, all are saying 4. No, all 4 are saying no. So you are right, and it's not in grayback normal form because of this. You can see there is a terminal symbol after the non-terminal symbol. I told you the terminal symbol in the grayback normal form is always the first symbol. And after that, you can have any number of non-terminals. Okay. So another information is grayback normal form is usually called as a prefix notation also. You have studied about prefix and postfix notations and data structures. Now let me write one grayback normal form grammar in grayback normal form. So let us take it like this. Okay. And I also told you that in each step, right, in each step, one terminal symbol is generated. So if I start from here, let me start from this, E derives plus AB. One terminal symbol has been generated. Now let me replace this A with 5. So it becomes 5B. You can see one more terminal symbol is generated. Now let me replace B by star CD. So star CD, one more was generated. And then C is replaced by 2. And let us replace D by 3. Okay. So you can see at each step one terminal symbol is done. Parsing is very easy, right? And you can derive this W. You can, if the W was given initially for you as can we generate W star 2, 3, this is the method we follow to tell yes it can be generated by taking the grayback normal form, right? So a few more advantages are the strings can be quickly parsed. Also, expressions can be efficiently evaluated, which you saw in the example above. Okay, so these are also a few advantages of grayback normal form. One more thing you need to know is every epsilon free CFG. For example, whatever CNF format we have seen, right? It's an epsilon free CFG has equivalent, means you can write an equivalent GNF for that. GNF. GNF is short for grayback normal form. Okay. Now I'll write only a very few simple examples now, and we'll leave the class in a 5 minutes. There are complicated examples also which will require you to go through some 3 steps. I'll just tell you what are those steps, and the problem will solve tomorrow. Okay. So now let me take an example, and whatever we are learning now usually is the third step for complicated problems. Okay, is the third step. So I'm just doing the third step now because it's simple, and then first, second and third step together we'll use it tomorrow. Not very complicated, that also it is simple because you have studied the first step already out of those 3 steps. So third step I'm doing, only second step I'll show tomorrow, and then we'll converge all the 3 steps. So let us take one example. S derives ABC and B derives B. And as you know, this is not in a grayback normal form. So in this example, all that I'm going to do, because only 2 productions are there, it's not at all complicated, I will introduce a new symbol. Introduce a new symbol for this. So this small c is the problem, right? So I'll introduce a new non-terminal and I'll call it as a capital C. I will call it as capital C, and capital C derives small c. That's all. So after I do this, you can see that this is in grayback normal form. This is also in grayback normal form. This is also in grayback normal form. All that I have done is replacing this small c with the capital C and writing capital C derives small c. Okay. Let's take one more example. So S derives BC, okay, and B derives B. Now here you have 2 problems, correct? You can see the first problem is, here I have a non-terminal followed by a terminal. Actually the format is terminal followed by any number of non-terminals, correct? So it's not sufficient only if I replace small c by c like I did in this example. Capital C I introduced, right, in place of small c. So that's not sufficient here. So all that I'm going to do is, this B also has to be converted into a smaller letter, right? So I will just write this B in place of this B. You can see B derives B. Single expression is there. So I will write small b instead of this capital B. So now it became BC. And this C cannot be small letter. So I will introduce a capital letter over there. And I will write a expression like this. I hope this is clear. Again, I'll repeat this if it's not clear. Let us say I have A derives BF. Okay. As you know, this should have been a terminal and this should have been a non-terminal. Okay. And I also had B derives B. So this is straightforward. Converting this non-terminal into terminal is straightforward because B derives B already is there. So I will write it as BF. And I can remove this because its only place was this. Only this B could have been converted to small letter. So it's not required anymore because I already replaced capital B by small b. The second problem is this should have been a non-terminal. So what I will do is introduce a new symbol called as F, and F derives F. I hope it is clear now. Okay. So you can do a similar thing for many other examples also, which we will see in the next class. But I'll tell you what are the 3 steps we are going to use for converting a given grammar to a grayback normal form. Let us say one step is, these are the major steps, okay? So convert the given grammar first to CNF, then it becomes very easy. Okay, convert it into CNF. So converting into CNF has a lot of steps, like you are going to remove epsilon translations, you're going to remove the unit productions, etc. So do all that and convert it into CNF. Now CNF grammar may have left recursion. So if it has left recursion, eliminate that left recursion. Very important step. Sometimes in the exam only this question also has come. Eliminate left recursion. Okay. And the third one is then convert this into GNF like I showed you. The format. That is a terminal followed by any number of non-terminals or a single non-terminal deriving the terminal. Okay. So you already know this, how to convert a given grammar into CNF. So I'm not going to do that. In tomorrow's example, I will take grammars which are already there in the CNF. Because we haven't seen left recursion, tomorrow we'll see how to remove left recursion, and then converting it to GNF already you saw how to do it. Right? So we'll solve one long, a little complicated problem tomorrow. So I'll stop for now. Is it clear whatever I did? Can you tell me in the chat box, is it clear? Yeah. If it is yes, you can mark your attendance.